In this video, we will use row reduction to bring this augmented matrix to its reduced row echelon form. We will not use the Gauss-Jordan algorithm though, because if we do, we will run into fractions almost immediately, and that will slow us down. We will still be looking to create leading ones and use them to wipe out the entries below them and above them. So take a look at this entry right here. We have 3, and what we want to do is we want to turn it into a leading 1. I don't want to divide the first row by 3 because then I'll end up with fractions. Now sometimes fractions are impossible to avoid, but we're going to try to do this for as long as possible. What I will do instead is I will use this 2 right here and subtract the third row from the first row, and that will give me a 1 in that pivot entry where 3 is right now. So what I will do is subtract the third row from the first. So I'll write R1 minus R3. And when I do this, I get 1, 0, 3, and past the vertical bar I get 2. My second row stays the same, 5, 3, 9, 13, and 2, 1, 4, and 5. And now I have a leading 1 in the pivot position right here in the first column. And I will use it to wipe out the entries below it. In other words, I'm going to get rid of 5 and get rid of 2. And I will do this in one step. I will take the second row and subtract 5 times the first row from it. And then I will take the third row and subtract twice the first row from it. And this gives me the following matrix: 0, 1, 0, 3, 2, so that's my first row. And then my next row is 0, 3, minus 6, 3. And then my last row is 0, 1, negative 2, and 1. So now my first column is ready. Take a look at the second row. We have a leading entry. We have a 3 there. And notice that we can actually go ahead and divide by 3 because 6 is divisible by 3, and so is 3. So what I'll do is I'll identify this as my pivot, and I will divide the second row by 3. So what I get is 1/3 R2, 1, 0, 3, 2 is my first row, and then 0, 1, negative 2, 1 is my second row, and my third row is actually the same as my second row, which is really nice because now if I subtract the second row from the third row, I'm going to put down R3 minus R2. What I will get is a row of zeros. So the first row is unchanged. The second row is 0, 1, minus 2, 1, and now I get a row of zeros like this. Well, take a look at this matrix now. We have leading ones right here, and the last row is 0. Check the entries above and below the leading ones. Those are all 0. So these entries are all 0, and so are these entries. And so we know we have an augmented matrix in reduced row echelon form, and we are done.